Hello everybody, get ready to do lesson 4.5 part 2 of pre-calculus math, graphs of sine cosine functions. We got 0 points here, notebook taking, and students, you have 38 points here on your class worksheet. Today's bell works. Teachers, plot the points and find the slope of the line passing through the points. Here's your 2 points here. Give your students 5 minutes, teachers. Okay, welcome back for your solutions for these two situations here. So our slope, 7 minus 1 and 2 minus 0 is 3. And then here is your plots here, and then find the slope of the line passing through. Well, we did it analytically. We really don't have to draw a line through it. And then down here, what do we do here? We went negative 2 minus 4, and then 3 minus negative 1, which is plus 1, so we have negative 6 over 4. 3 over 2 is our slope, so we found the slope there. This would be your plot here, so you have a negative slope falling from left to right. Into our lesson. Translations of sine and cosine curves, the constant c in the general equations y equals a sine quantity bx minus c and y equals a cosine quantity bx minus c creates a horizontal translation of the basic sine and cosine curves. Comparing y equals a sine bx with y equals a sine bx minus c, you find that the graph of y equals a sine bx minus c completes one cycle from bx minus c equals 0 to bx minus c equals 2 pi. So we have kind of like a zero situation here, solving for zeros, and then 2 pi. By solving for x, you can find the interval for y to be c over b is less than or equal to x, so this will be your left endpoint here, and then over here will be your right endpoint, cb plus 2 pi over b. So we have a lot of symbols here to take heed of. This is on your class worksheet, and then this is your period here, 2 pi over b. Remember, this is how you find your period. This whole thing added together is the sum that determines your right endpoint, and then this is your left endpoint here. So this implies that the period of y equals a sine quantity bx minus c is 2 pi over b, and the graph of y equals a sine bx is shifted by an amount of c over b. So this is your shift here, c over b, c over b. The number c over b is the phase shift. It's called a phase shift. So to determine that, graphs of sine and cosine functions, page 3 on your class worksheet. The graphs of y equals a sine quantity bx minus c and y equals a cosine quantity bx minus c have the following characteristics. Assuming b is greater than 0, the amplitude is the absolute value of a, so out here is your amplitude. Your period is 2 pi over b, so here is your b in each one of these graphs. This determines your period. And then the left and right endpoints of one cycle interval can be determined by solving the equations bx minus c, so we have bx minus c equals 0, and then bx minus c equals 2 pi. So bx minus c equals 0, then bx minus c equals 2 pi. That will determine the length of one cycle of an interval. So let's try one of these now. Example 4, horizontal translation. Analyze the graph of y equals 1/2 sine quantity x minus pi over 3. So the amplitude is 1/2. Here's your amplitude. And the period is 2 pi. So 2 pi is 2 pi over b, which is 1 in this case. By solving the equations x minus pi over 3 equals 0 and x minus pi over 3 equals 2 pi, we get x equals pi over 3, and then x equals 7 pi over 3. So that determines our left endpoint and our right endpoint of our interval. So pi over 3 and then 7 pi over 3 corresponds to one cycle of the graph. So pi over 3 and 7 pi over 3. Here's your pi over 3 here, and then 7 pi over 3 would be out here, and then into 4 equal parts. Dividing this interval into 4 equal parts produces the following key points. So now that we know of the length of an interval, we can divide that into 4s, and we get pi over 3, 0, so pi over 3, 0 here. Then 5 pi over 6 will be 1/2, 4 pi over 3 will be back to 0, and then 11 pi over 6 will be negative 1/2, and then 7 pi over 3 will be back to 0 again. So that would be the ways you would divvy that up. There's your pi over 3, 0, and then 5 pi over 6 will be 1/2, which will be up here. 4 pi over 3 will be back to 0, and then 11 pi over 6, which would be between 5 over 3 and 6 over 3 pi, would be back to negative 1/2, and then 7 pi over 3, which would be out here again, would be 0. So that's the idea here. Once we find our interval, the length of our interval, we divide that into 4s, and then we get this here. And then that would be your basic sketch there of the excuse me. So, using a graphing calculator set in radian mode to graph y equals 1/2 sine quantity x minus pi over 3, use the minimum and maximum and zero or root features of the graphing utility to approximate the key points. So when we do that here, when we use max, zero, or root features, we can find our points here. After we graph this, we can trace along and then find those. And we can also go in the table to find those as well. Okay, let's try one. So we got y equals sine quantity x minus pi over 4. Sketch graph, then use the graphing calculator to verify your sketch. Includes 2 full periods. So a equals 1, b equals 1, here's your b here, then c equals pi over 4. And then our period here will be 2 pi, because we have 2 pi over 1 here, b equals 1. And then the amplitude will be 1 here. 1, your amplitude's out here. So the shift set equals x minus pi over 4 equals 0, and then x minus pi over 4 equals 2 pi. That is what they call our shift here, or the length of the interval. X equals pi over 4, and then x equals 9 pi over 4. So that would be your interval there. And then when we divide these up into 4s, we get these points here: pi over 4, 0, 3 pi over 4, 1, 5 pi over 4, 0, 7 pi over 4 equals negative 1, and then 9 pi over 4 back to 0 again. So the basic shape of that graph would look like this here for this example, 49. Okay, so let's try another example. Horizontal translation. Here's our graph here. Y equals negative 3 cosine quantity 2 pi x plus 4 pi. So the amplitude is 3 here. So our amplitude is the absolute value of this number out here. Negative 3, the absolute value, that would be 3. And the period is 2 pi over 2 pi, which would equal 1. So we have a period of 1. By solving the equations, 2 pi x plus 4 pi, 2 pi x equals 0, and then 2 pi x plus 4 pi equals 2 pi. So we're solving this to find our interval length. So 2 pi x equals negative 4 pi, and then we continue to solve that. X equals 2, and then over here 2 pi x equals negative 2 pi, x equals negative 1. So what we have over here on this side of your y-axis is negative 2 and negative 1. So it would be negative 2, negative 1 would be the length of our interval here. Of course, one cycle of the graph. So for that, divide this interval into 4 equal parts. Negative 2, 3, negative 7 over 4 is 0. The maximum will be negative 3 to negative 3 over 2 equals 3. And then our intercept will be negative 5 over 4, 0. So we're all over in here. And then negative 1, when x equals negative 1, y equals negative 3, back down here again. So we got something like that. So here's our points here. When x equals negative 2, y equals negative 3. When x equals negative 7 fourths, y equals 0. And then when x equals negative 3 over 2, we have back up to 3. And then when x equals negative 5 over 4, back to 0. And then when x equals negative 1, y is back down here to negative 3. So here would be one cycle here. And then if you articulate those points, you get something like this is what you would get. So using a graphing calculator, set in radian mode to graph y equals negative 3 cosine quantity 2 pi x with 4 pi as shown in the graph. Use the minimum, max, and zero or root features of the graphing calculator to approximate the key points. So here are your key points again. Here, another way of putting them from up here. Here are your key points here. And then this is the way that if you set your viewing window correctly, this is what you should have here as your function for that. Okay, let's try one. Use a graphing calculator to verify your sketch. So we have negative 8 cosine quantity x plus pi here. So our period is 2 pi. So we have 2 pi, b is here, and b is 1. 2 pi is our period. Amplitude is 8. And then here are our key points here. Minus pi, negative 8. So we have down here when x equals negative pi, y equals negative 8, and then when x equals negative pi over 2, back to 0, and then when x equals 0, y equals 8, and then when pi over 2, when x equals pi over 2, y equals 0, back down to there. Then when x equals pi, y equals negative 8 here. So here is the basic shape of one cycle of your graph. And when you articulate that, that's what it would look like. And then this is like the basic shape of that function in a graph. And that is your 4.5 part 2 lesson. Pre-calculus math. Email me here for questions or course materials. Thank you very much.